All right, so this video is going to go over the lesson from Monday, October 19th, which is review for the quiz that's tomorrow, Tuesday, 10:20. Okay, function/graphing linear equations quiz. All right, so the first question was plotting the ordered pairs, which go x comma y on the coordinate plane provided. Okay, first one is 3 comma 5. So you always go x comma y for our coordinate points. So you start on the x-axis and then you go up or down based on what the y-axis says. So start at 0, 0. You're going to go to 3 on the x. The x coordinate is 3, so 3 on the x-axis. And then up to where 5 is on the y-axis. Okay, so this is our point, 3 comma 5. 3 comma negative 5. Go to 3 on the x-axis, because x goes first, and then to negative 5 on the y-axis. This is 3, negative 5. Okay, so negative 7, 2. Go to negative 7 on the x-axis, and then our y-coordinate is positive 2. Negative 2, negative 4. Negative 2 on the x, negative 4 on the y-axis. Okay, these are the tricky ones that everybody always gets stumped on, so be careful. 0 comma 6. The x-coordinate is 0, and the y-coordinate is 6. So my x-coordinate is 0. I'm not going to go anywhere left to right. But then for my y, I'm going to go up to 6. Now the opposite, 6 comma 0. So my x-coordinate is 6. So I'm going to go to 6 on the x-axis. But then my y-coordinate is 0. So I'm not going to go up or down at all. All right. Number 2. Determine if each of the following relations is or is not a function. Okay, so first we have a mapping situation here. So we have to see, in order for it to be a function, the x values cannot repeat. So let's make a note of that. The x's cannot repeat. Now, that's the easy way to remember it, but you also need to understand the mathematical definition, which is that each input corresponds to only one output. Okay, so let's look back at these points now. So we have 8 is the input going to negative 2 as the output. Then we have 5 input, 9 output, 7 to negative 2, and 1 to 3. You don't have to list the points like this, but it does often help because then you can look and see if the x's are repeating, and they're not. So each input is assigned to only one output. Notice this negative 2. Oops, I skipped that. Oh no, right here. Negative 2, the y-coordinate, that's repeating. But it's okay for the y-coordinate to be repeating because each input is still assigned to only one output. It's not like you have 8, the input of 8 being used twice. So this is fine. So this one is, yes, a function. Okay, now we have a set of points. So let's look at just the x-coordinates. We want to see if each input is paired with just one output. So the x's can't repeat. 3, 5, negative 2, and negative 1 are our x-coordinates because it goes x comma y. Remember, x and then y. So let's see, none of them are repeating, so that means yes, it's a function. Okay, now let's look at a table. All right, so again, the x's cannot repeat. Each x value is just paired with exactly one y value. 3 to 0, 4 to 7, 5 to 10, 4 to 14, 10 to 25. So let's see, right here we have 4 being paired with 7 and also 4 being paired with 14. So you have 2 different points here that have 4 as the x-coordinate. Therefore, this is not a function. You cannot have an input of 4 being paired with 2 different outputs. Okay, for these 2 graphs, you have to do the vertical line test to see if it's a function. To be a function, it has to pass the vertical line test. So you want to draw a vertical line going up and down through your graph, and see how many times it crosses. This vertical line hits our graph twice, so we know that it's failing the vertical line test. So it is not a function. Now this graph, if I draw a vertical line going through it, it hits just once. We could draw a vertical line here, hits just once, hits just once. No matter where you draw a vertical line, it's just going to hit once. So we're good. It's a function. Passes the vertical line test. Failed the vertical line test. Okay. All right, graph each of the following equations using the slope and y-intercept. All right, so y equals mx plus b is our slope-intercept form. So let's figure out what the m is and what the b is. So I'm going to write my equation above it. M and b. Y equals mx plus b. So the m is the number right in front of the x, the coefficient of the x. So here it's the fraction negative 2/3. That negative we always like to put up with the numerator, even though it looks like it's right in the middle of the fraction. Focus. Okay. Okay, so this tells us that we're going to be moving down to right 3. Our y-intercept, you can't see any number being added or subtracted at the end here. So that means it's as if there is a plus 0. So that means our y-intercept is going to be 0, 0. B tells us where to begin. We're going to begin at the origin. The y-intercept is 0, 0. Right, so this was our slope. This is our y-intercept. 0, 0. Okay, so now we can graph. We're going to begin at 0, 0, because this is just y equals mx. There's no b that you can see. It's just 0. It goes through the origin. Now we're going to move down 2 and right 3. Down 2, right 3. Down 2, right 3. Down 2, right 3. Reverse would be going up 2, left 3. Up 2, left 3. Connect. Label y equals negative 2/3 x, and don't forget your arrows. Right, so again, this one, because it was just in y equals mx form, there was the plus b really wasn't there, didn't exist, it's just plus 0. That means it's going through the origin. All right, now let's try one that does have a b that's visible. Y equals mx plus b. Our m is 2 right here. Our b is this minus 4, which we're going to represent as negative 4. Okay, now we like to write our slope as a fraction, so we're going to put that whole number over a 1. Now it's positive, so that means we're going to be going up 2, right 1. We're going to begin at the point 0, comma, negative 4 on the y-axis. Okay, so let's do that. We're going to begin at the b, begin at negative 4 on the y-axis, the point 0, comma, negative 4. And then we're going to move up to right 1 because our slope is positive 2. Up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Reverse down 2, left 1, down 2, left 1. Y equals 2x minus 4. Goes through negative 4 on the y-axis, and the slope is 2 over 1. All right, number 4. Rearrange each of the equations below so that they are in y equals mx plus b form, then label or identify what the slope and y-intercept are. Okay, so our goal is to have them be in y equals mx plus b form. These are not, so we're going to move some things around. All right, so let's take a look at this one. We want to get the y all by itself and then everything else on the right. So this plus 5 is in the way. We're going to minus 5 on both sides. then we're left with y equals 3x minus 5. You cannot combine the 3x and the minus 5 because one term has an x and the other one doesn't. So you just have to leave them as 3x minus 5. Put the term with the x first because it's y equals mx plus b. We want the term with the x to come in front of the constant. Okay, then we just have to identify the slope and the y-intercept. So the m would be 3 and the b would be negative 5. All right. Okay. And just know that the y-intercept then would be the point 0, negative 5. And this could also be written as a fraction. All right, moving on. Negative 4y equals negative 20x plus 40. Okay, so we want to get this y all by itself. This negative 4 is being multiplied by y. Opposite of multiplying by negative 4 is dividing by negative 4. But we need to divide everything by negative 4 then. So I'm going to have my y all by myself. That's great. But now let's divide everything by negative 4. So negative 20x divided by negative 4. A negative divided by a negative is a positive. 20 divided by 4 is 5. And then we have an x. So that would be 5x. Then we also need to divide 40 by negative 4. 40 divided by 4 is 10. A positive divided by a negative is a negative. Y equals 5x minus 10 is our rearranged equation in y equals mx plus b form. And now let's just label what the m and the b are. So the m would be 5. Our slope is 5. And our b is negative 10. So that means our y-intercept would be at the point 0, negative 10. So this is our y-intercept. And our slope is 5 or 5 over 1. Same thing. We like to put 5 over 1 when we're graphing, but since we're not graphing right now, we can just say 5. Okay, I'm just going to go back and label these a little bit better. So this is our slope. And this was our y-intercept. Okay, last one, our superstar problem. All right, let's see if we can handle this one. So negative 2x plus 5y equals 35. Let's get the y all by itself. First, we want to move this negative 2x out of the way. This 5 is like glued to that y. It's being multiplied by. We have to save that for last. So let's add 2x to both sides. And then we're left with 5y equals 2x plus 35. Remember, put the term with the x first. Trying to get to be y equals mx plus b. We're almost there. We just need to get rid of this 5 that's being multiplied by y. So the inverse would be to divide by 5. But that means you need to divide everything by 5. We're left with y equals 2/5 x plus 7 when you do 35 divided by 7. Leave the 2/5 as a fraction. We like to leave slope as a fraction, not a decimal, so that we're good. It's a simplified fraction. Okay, let's figure it out. Mx plus b. The m, which is our slope, is 2/5. And our y-intercept would be 7, which would be the point 0, 7. Okay, there we go. All right, I hope that helps. We're done with the review. Happy studying. Bye.